Now let's try this example. Earlier we have seen this. Let us say there is a box, and in the box we have 1, 2, 3, 4, 5 fair coins, and 1, 2, 3, 4 unfair coins. So in unfair coin, probability of getting a head is equal to, let's say, 1 by 3, and probability of getting a tail equal to 2 by 3. Total is 1. And in fair coin, probability of getting a head equal to probability of getting a tail equal to 1 by 2. And now various questions can be asked on this. So earlier we have solved a question that, see, I hope you remember the experiment. We are going to choose one of the coins randomly, and then we are going to flip. Now earlier question was, what is the probability that you will get a head, or what is the probability that you get a tail, which means we wanted the total probability of getting a head and we wanted the total probability of getting a tail. How did we do that? So the total probability actually depended here on two cases, right? See this, probability of getting a head actually depended on two cases. One is probability of drawing the fair coin, and when I flip it I get a head, plus probability of drawing the unfair coin, and when I flip it I get a head. This is nothing but probability of getting the fair coin into probability of getting head, given that we have the fair coin, plus probability of getting the unfair coin into probability of getting a head, given that we have chosen the unfair coin, right? And similarly, what is the probability of getting a tail? Same thing, probability of getting it depends on probability of getting a fair coin intersection probability of getting a head, plus getting an unfair coin and a tail, this is a tail, which is nothing but probability of getting a fair coin into probability of getting a tail when that fair coin is flipped, plus probability of getting an unfair coin into probability of getting a tail when that unfair coin is flipped. Now these are the total probabilities which we already know, right? So if you want, what does this evaluate to? We know that probability of getting a fair coin is nothing but 5 by 9 here, right? And what about probability of getting a head, given that it is a fair coin? For fair coin it is 1 by 2, plus probability of getting an unfair coin is 4 by 9. And what is the probability of getting a head for unfair coin? See, for unfair coin it is given that probability of getting a head is 1 by 3. See, this probability of head and this probability head of different. This is probability of head given that it is unfair coin, right? Conditional probability. And similar way you can even evaluate this. What is the probability of getting a fair coin? It is 5 by 9, because there are totally 5 fair coins out of 9 total coins. And what is the probability of getting a tail, given that it is a fair coin? It is 1 by 2. And what is the probability of getting an unfair coin? It is 4 by 9, because there are 4 unfair coins out of total 9 coins. And what is the probability of getting a tail, given that it is unfair coin? It is 2 by 3. So these things, total probabilities, we can evaluate. Now let's talk about the reverse probability using Bayes' theorem. So what are the various questions they might ask is, one is, what is the probability that the coin happened to be fair coin, given that we got a head? I'm listing down all the possible questions, okay? Similarly, what is the probability that the given coin happens to be drawn coin happens to be a unfair coin, given that we got a head? Similarly, what is the probability that the coin which we have drawn happened to be a fair coin, given that we got a tail? Similarly, what is the probability that the coin happened to be unfair, given that we got a tail? Now how can we do this? Again, by using Bayes' theorem, we know that whenever we have to do this one, it is P of F intersection H divided by P of H. This is one way of doing it. Now what is P of H? P of H is nothing but probability of total probability of getting a head, which is this one. So you substitute this entire thing in P of H, and in place of P of F intersection H, so F intersection H is going to be this part. Got it? So denominator is going to be this part which we evaluated, and numerator is going to be this one. Got it? And what about this one? What is the probability that the given that the coin happens to be unfair, given that a head is we got a head is equal to probability of u intersection h divided by probability of h. Now what is p of h? It is the total probability of getting a head, which means this entire thing. What is u intersection h? Again, it is nothing but p of u into p of h given u, right? You can evaluate it. And similarly here also, what is probability of getting a what is the probability that the coin which we have drawn happens to be a fair coin, given that it is a tail? Then it is nothing but f intersection t divided by p of t. Now we know the total probability for tails. Total probability for getting a tail is this one. And what about f intersection t? F intersection t is this one, right? What about this? Again the same way, p of u intersection t divided by p of t, and we know that p of t is nothing but total probability which we have evaluated here, and u intersection t is nothing but this factor. Got it? You can substitute those factors here and you can get these reverse probabilities. In exam they might ask you only one of them, and this can be evaluated using Bayes theorem like this. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.